Welcome. In this video, we're going to go through the solutions to the 30 multiple choice questions that appeared on the May 2016 SL Chemistry exam. So this was the first exam given with the new set of curriculum guidelines. So there's your periodic table as you get on paper 1, but remember, no calculator and no data booklet. Question 1, which equation represents sublimation? So they started you off with a nice easy one because remember, sublimation is simply a physical change from a solid to a gas. So the only one here that represents a physical change going from a solid to gas is B. A is a chemical change, D is a chemical change, and C is actually the opposite process, deposition. Question number 2, for which compound is the empirical formula the same as the molecular formula? So when you look at the molecular or the molar mass here, it would have to be the same molar mass as what the empirical formula would give you. So in your head, you've got 12 plus 32 is 44, 45. So that one's not going to work. It's twice as much. B, you've got 12, 15, Brown 31. So that's going to be twice as much, so that one's not going to work either. C2 is going to be 24, 28, and 16. That's only going to be about 44, so that's not enough. C4, 48 plus 8 is 56 plus the 16. There we have one. 72 is the empirical formula's mass as well as the molar mass given. Number 3, in which mixture is NaOH the limiting reactant? Well, what you have to realize is sulfuric acid gives you 2 hydrogen per mole. So in this first one, I've got 0.2 molar, so I'm going to have 0.2 moles of NaOH, or OH ions, but I'm also going to have 0.2 moles of H plus ions because I get 2 for 1 from the sulfuric acid. Second one, I've only got 0.1 OH, and I've got 0.2 H plus. The third one, I've got 0.2 OH. And now because it's HNO3, I only have 0.1 H plus. And the third one, I have 0.1 OH and 0.1 H plus. So the only one where NaOH is actually the limiting reactant is B. Number 4, why do gases deviate from the ideal gas law at high pressures? Well, remember, the definition of ideal gas is no volume and no intermolecular forces. So A, molecules have finite volume. That is true, and that is one reason why they tend to deviate at high pressures. That finite volume becomes obvious. Cohesive forces increase the volume. No, that's not going to be true. Increasing pressure increases the temperature. That's true, but it doesn't explain why it deviates. Collisions between molecules occur more frequently as pressure increases. That's also true, but it doesn't explain why it deviates. So only A explains the deviation. Number 5, which is correct for the chromium isotope? So I'm given 53 and 24 as my data. So that lets me know that 24 is my protons or my electrons, either one. And then when I subtract 29 are my neutrons. And the nucleons are both protons and neutrons, the stuff in the nucleus. So the only one that fits those numbers would be C, 24 protons and 29 neutrons. Number 6, which electron configuration is correct for the selenide ion Se-2? So if you look, normally it has 34 electrons. It's gain 2, so 36 electrons. So it should have the noble gas configuration of krypton. A and B are wrong because they have the 410 instead of the 3d10. C is just the Se atom, but D would be the 2- ion. Number 7, which element is a metalloid? This is just looking at the periodic table and seeing which one is along the line. And the only one that is B, arsenic. C, which periodic trend is described correctly? Well, atomic radius should increase as you go down, but it will decrease across the period, so that one's not going to work. Ionic radius should have the same general trends, although it's going to vary with positive and negative ions, so that's going to be a tough one to compare, so I'm going to eliminate that. First, ionization energy decreases down the group, but it increases across. So only D is true. It decreases down the group as they get larger and increases as you move across and they get smaller. Number 9, which molecule is nonpolar? So these you might have to think about sketching quickly, but if you think about it, oxygen will often, with just 2 bonds, you can expect it to have 2 lone pair. Nitrogen with 3 bonds, you can expect it to have a lone pair. BF3 is the one that typically is trigonal planar because it's only capable of forming single bonds. And SO2, you may or may not remember, often has resonance with that extra double bond. So if you had to just make a quick guess, BF3 is the one incomplete octet along with BeF2 that is often mentioned, and that makes it nonpolar because of its symmetry. Number 10, which compound contains both ionic and covalent bonds? Well, ionic and covalent bonds usually occur when you have a polyatomic ion because the polyatomic ion will bond covalently and then that bonds to a metal ionically. So SiH4 is going to be covalent. NaNO3, that's got your polyatomic ion covalently bonded and the metal. C is just covalent, and D is just ionic. Number 11, which compound has resonance structures? Resonance structures also often occur in polyatomic ions. So C6H12, that's just going to be a long carbon backbone, and even though it's got a double bond in it, that's not going to give it resonance. B, CH3CHO, that's going to have, it's an aldehyde group, so it's going to have a carbon double bond at the end, but again, that's not going to resonate. NaCN is going to have a triple bond between the carbon and nitrogen, but a single bond with the sodium, so no resonance. But it's the Na2CO3 because the CO3 is where the resonance occurs. This bond will resonate between, among the oxygen, whereas this one is where the electron will be donated to the Na. Number 12, which of the following are van der Waals forces? Dipole-dipole, hydrogen bonds, or London dispersion forces. Those are all considered van der Waals forces. So D would be the choice I would make. Now, some may argue that hydrogen bonds don't fit in there, but I have always been taught that hydrogen bonds are the third and final type of van der Waals forces. Van der Waals referring to any intermolecular force. Number 13, when 25 cc's of 0.1 molar NaOH is mixed with 25 cc's of 0.1 molar HCl at the same temperature, a temperature rise is recorded. What is the expression in kilojoules per mole for the enthalpy of neutralization? Assume the density of the mixture is 1 gram per cc and its specific heat is 4.18. Well, this one I have a little trouble with because when I come up with it, I'm going to use 50 grams as my mass because I've got 25 cc's of each at a mass of 1 gram per cc. So there's my M. They said to use 4.18, and I'm trying to find delta T. And then on the bottom, if I'm trying to do this in kilojoules per mole, I have 50 cc's again at 0.1 molar, but the 0.1 molar is in moles per liter, so this should have been changed to 0.050 liters. So the closest one I can find is C. D, what is the enthalpy of formation of ethine represented by the Y arrow on the diagram? So this is the area I'm looking for. Well, this one's actually pretty straightforward because this section right here, less these two sections, will yield that. So I just have to flip this arrow over to a positive 1301 and then add it with the other two equations, which have enthalpy changes of minus 788 and minus 286, and that would yield Y. So A would account for that. Number 15, which equation represents the average bond enthalpy of the SiH bond? Well, number one, this looks like it would work because there is just one SiH bond being broken, but there's actually a better answer in B because here you have 1/4 of the bond broken to give you 1/4 of the Si. So this actually shows an average as opposed to just a single bond being broken. C is a poor choice because you're forming an H2 bond, and D is a poor choice because you're breaking all four but not averaging it. So average bond enthalpy, B would be the best choice. 16, which conditions must be met for a reaction to take place? Reactions collide with sufficient energy, that's true. Collide with the correct orientation, that's true. Must be in the same state, that is not true. So A, 1 and 2 only. Number 17, we see a plot of carbon dioxide against calcium carbonate with 1 molar HCl, and acid's the limiting reactant covering lumps of CaCO3. So what set of conditions would give the two different graphs? Well, I'm seeing the same yield on each of these. And since acid's my limiting reactant, that means my concentration of HCl has to be the same for both. So it's either so 1 molar has to stay the same, for each of them, and 0.05 isn't an option because I know that graph 1 is 1 molar. So since it's the same yield, my answer is either A or C. So then, would larger lumps or smaller lumps give me the second graph? Well, the second graph is faster. That's what the slope is showing me, is the reaction happened faster. So I can assume they use smaller lumps of the calcium carbonate. Number 18, what's the effect of increasing temperature on the equilibrium? Well, I see this as exothermic, so increasing the temperature is going to be like adding a product, or it's going to favor the reverse endothermic reaction. So it's going to move the equilibrium left, not right. And when you move it left, you have a decrease in product over the reactant, so Kc also decreases, or A. Number 19, which is a conjugate Bronsted-Lowry acid-base pair? Well, this is a pair and this is a pair because we're looking at hydrogen being donated and accepted by two different species. So the only one that matches up there is C, H2O and H3O plus. Which of the following gases does not result in acid deposition? Well, NO2, NO, and SO2 all form, I should be putting an X there, these all form strong acids, either HNO3 or H2SO4. And that is what contributes to acid deposition. CO2 is naturally in the air and always has been and forms the weak carbonic acid in there. So that one does not contribute to acid deposition. 21, applying IUPAC rules, what is the name of MnO2? Well, make sure you realize it's manganese, not magnesium, so that eliminates 2. And oxygen with a -2 charge would have a -4 charge. So we're looking at D, manganese 4 oxide. Number 22, which statement is correct for a voltaic but not for an electrolytic cell? An electrolyte is required. That's needed for both. It's just whether it's in one cell or two. The anode is where oxidation occurs. That's also true for both. Ions move in the electrolyte. That's also true for both. Electrons flow from the negative electrode to the positive electrode. That is true for a voltaic, but it's different for an electrolytic because the power source is pushing electrons toward the negative cathode versus in the voltaic cell where the electrons flow from the negative to the positive as a result of the redox reaction. 23, how many alcohols have the general formula C4H10O? So if I look at this, I could put all 4 carbons together and put the OH at the end, or I could put the OH on the second carbon. And then I also can branch this, and I could put the OH on the end of one of those branches, or I could put the OH on the center atom. So I'm coming up with a total of 4. The general formula for the alkyne series then, I'm going to have a triple bond, so if I draw one, I'm just going to draw one with 3 carbon in there. I'm going to need 1 hydrogen here, no hydrogen on the center, and 3 on the end. So if I look at that formula, I've got C3, and I've got 1, 2, 3, just 4 hydrogen. So the general formula is going to be Cn, and then the H2n, I'm going to have to subtract 2 to get to that, because 2 times 3 is 6 minus 2 gives me the C3H4. So B would be the correct choice. And since you've got the options to choose for, you could quickly, plug these numbers in and see which one fits that, since you're not having to create the formula yourself. You just have to recognize it. 24, which compound can both be esterified and turn acidified potassium dichromate solution green? So they're talking about an alcohol here, because esters are alcohols plus carboxylic acids or organic acids. But potassium dichromate, that's a catalyst with oxidizing alcohols. And what you have to remember is that you can only oxidize secondary and primary alcohols. So even though A and B are both alcohols, only both A and C are alcohols, only C is a secondary alcohol. A is a tertiary, so it is not going to work for the acidification there. 26, what is the mechanism of the reaction between ethane and chlorine? Well, ethane is going to be a substitution reaction. That's what makes ethane so stable, is you have to actually bump something off to react with it. And it does undergo that free radical mechanism, but it is free radical substitution, not addition. 27, a measuring cylinder was used to obtain a known volume of liquid. The volume was read from the top, and the liquid completely emptied into a flask. The exact same process was repeated. What statement could be made about it? Well, this is systematic error, when you're misreading your equipment, and the results aren't going to be accurate. They're going to be precise, but systematic error always brings in some inaccuracy. 28, what is the relationship between the two variables sketched? A says y is proportional to x. That's not quite true, because y proportional to x, I would expect it to have a positive slope going the other way. B, inversely proportional, that yields an exponential graph. C, y is proportional to negative x, that would give me a positive slope. And then D, again, we're talking exponential. So the one that's going to give me the graph shown here would be C. 29, which feature of a molecule can be determined from its proton NMR spectrum? And that is your number of hydrogen environments. Number 30, which molecule has an index of hydrogen deficiency equal to 1? So with A, that one I recognize as benzene. So that one I know is going to have 3 double bonds, and that's going to be 3. With B, if I draw C2, Cl2, this one I would need 1, 2, 3, 4 hydrogen, and I don't have any, so that's got a deficiency of 2, 4 divided by 2. With C, if I draw in my 4 carbon and a nitrogen, I would need 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I would need 11 hydrogen, but I only have 9. So that's 2 hydrogen I'm short, or 1 hydrogen molecule for a deficiency of 1. And D then, I've got C2, H6O, so I'm going to need 1, 2, 3, 1, 2, OH there. So that actually is saturated or at 0.